So hello students, welcome once again to our TEJAS series. So those were the two questions. Let's solve the first ones. Both the questions are from series and they are very special, quite different questions. So those who would have tried these questions would have found that they are really very different and I will say very new type of questions. Okay, so let's start. Let's solve the first one, which says we have to evaluate the value of this series, which is sine of nx over 2 raised to the power n goes from 1 to infinity. See how I started thinking. See, in denominator, of course, we can see it's a GP. It's like 2 square, 2 cube, and so on and so on. So if I open it, so the first term is sine of nx by 2, rather sine of x, because n is 1 by 2. Then put n is equal to 2, so sine 2x by 2 square, sine 3x by 2 cube, and so on bachcho, till infinity. The point is that as I said, we can find a GP in denominator. Okay, but what about numerator? How will you take care of the the change in the angle within sine, and that forms an AP. Okay, so the first thing that should strike your mind, and that's how I solved it, is the use of complex number and De Moivre's theorem. Okay, so what is it? It simply says that if your z is in the form of cos theta plus iota sine theta, okay, you can put r also, doesn't matter. So z is to the power n if n is an integer, though it is nothing but cos n theta plus iota times sine of n theta. So the power appears as product within the trigonometric function with the argument of complex number. Okay, so what does that mean? That means if I consider something of the form where the power increases as the power of denominator is increasing. Okay, something of the form means something in this form whose power increases as the power of denominator increases, and then if we equate the real part and the imaginary part, we stand a chance that we will be able to get it. Okay, so now let's try it. See, so how we need to think. So I will say, so what I said, okay, let me consider something in this form, e raised to the power iota x. Okay, that means cos x plus iota sin x upon 2 e raised to the power iota x whole square upon 2 square e raised power iota x upon 2 whole cube. Can't we write this? E raised power iota x upon 2 whole raised to the power 4. So now that's an infinite GP with the common ratio as e raised power iota x by 2, e raised power iota x by 2. And maybe what's wrong if I consider 1 here? Okay, if I consider 1 here, so with the first term as 1. Okay, now the sum of such an infinite GP is 1 upon, or any infinite GP is A, the first term upon 1 minus R. So if I start my series, or if I write my infinite GP as this, so A is 1, e raised power iota x by 2 is the common ratio. So now I will say, let us consider the infinite GP, the same which I wrote here. Okay, and then this is equal to, so let us consider, let me rewrite the infinite GP which I wrote on the previous slide, bachcho, infinite series GP. Okay, so whose sum is nothing but 1 upon 1 minus e raised to the power iota x by 2. I think all of you agree. Okay, now take its LCM, so it's 2 upon 2 minus e raised to the power iota x, so 2 upon 2 minus cos x plus iota sin x. Okay, now if I rewrite my series, so this is nothing but 2 upon 2 minus cos x minus iota sin x, bachcho, fine. Now that's our LHS. So what we have in RHS, I am rewriting 1 plus e raised power iota x by 2, e raised power iota x by 2 whole square, and so on and so on. Now how will we get our required series? See, collect its imaginary part and real part. See, so you get an idea here, bachcho, to frame one more question which will give you the another type of series like cos x series. So 1 plus cos x by 2 plus here when you write e raised power iota x as cos x plus sin x and use De Moivre's theorem, you will get cos 2x by 2 square if I am collecting the real part, and when I write here for the imaginary part, so what will we get? So there is no imaginary part in 1, so we will get sin x by 2, sin 2x by 2 square, sin 3x by 2 cube, and so on. So that means our series, where is it? So that's our series. So our series is equal to, the value of this series is equal to, when you equate, of course, our complex numbers are equal, then the real part, imaginary part have to be equal. So you have to get its imaginary part. So you will say, okay, so therefore series is nothing but imaginary part of, so let's realize the denominator, convert the denominator to a real number, so multiply and divide by its conjugate, 2 times 2 minus cos x iota sin x, isn't that? Bachcho, upon, so it's 2 minus cos x whole square, z into z bar is mod z whole square, mod of z, modulus of z is under root of real part square plus imaginary part square, so real part square plus imaginary part square. So it's imaginary part, so forget about real part, imaginary part is 2 sin x by, solve it, so 4 plus 1 is 5 minus 4 cos x if I am not wrong, so that should be the answer. If you wish, you can further simplify it by converting it to half angle or whatever, okay, but this is how we can solve this series with the help of concept of infinite GP and complex number, and particularly the De Moivre's theorem, bachcho.